Humans have always been stargazers. Since our earliest ancestors first looked up at the night sky, we've been captivated by the celestial tapestry of stars. We've spun tales about the constellations, used them to navigate across vast oceans, and pondered our place in the grand scheme of the cosmos. But to truly understand the universe and our place within it, we need a system to map and measure the vast distances and movements of celestial objects. That's where celestial reference frames come in. Imagine trying to give someone directions without a map or street names. It would be nearly impossible. Celestial reference frames are essentially the universe's coordinate system, providing a framework for pinpointing the positions and movements of stars, planets, galaxies, and other celestial objects. They're the invisible grids that allow us to chart the cosmos and understand our place within it. In the simplest terms, a celestial reference frame is like a giant imaginary grid superimposed on the sky. It allows astronomers to define the positions and movements of celestial objects relative to a fixed set of reference points. Just as we use latitude and longitude to define locations on Earth, astronomers use celestial coordinates to map the heavens. These celestial coordinate systems use angles to pinpoint the location of an object. Imagine you're at the center of a giant sphere, with the Earth below you and the stars all around you on the surface of the sphere. That's the basic idea behind a celestial sphere, and the angles used to define positions on this sphere are called right ascension and declination. For centuries, the prevailing view of the universe was geocentric, meaning Earth was considered the center of everything. This made sense intuitively. After all, the sun, moon, and stars all seem to revolve around our planet. The earliest celestial reference frames, therefore, were geocentric, with Earth as the fixed point. However, as astronomical observations became more precise, it became clear that the geocentric model couldn't accurately explain the movements of the planets. In the 16th century, Nicholas Copernicus proposed a revolutionary idea, a heliocentric model, with the sun at the center of the solar system. While initially controversial, this model ultimately provided a simpler and more accurate explanation of celestial motions. Today, astronomers use a variety of celestial reference frames, each tailored to specific purposes. Some are geocentric, still useful for Earth-based observations, while others are heliocentric or even galactocentric, with the Milky Way's center as the reference point. One of the most widely used celestial reference frames is the International Celestial Reference System, or ICRS. This system is based on the positions of distant quasars, incredibly bright and distant objects that serve as fixed reference points in the universe. The ICRS provides a highly accurate and stable framework for measuring the positions and movements of celestial objects. Section 5: Celestial Navigation, from ancient sailors to spacecraft. Celestial reference frames have played a crucial role in navigation for centuries. Long before the invention of compasses and GPS, sailors relied on the stars to guide them across vast oceans. By measuring the positions of certain stars, they could determine their latitude and longitude, allowing them to navigate with remarkable accuracy. Even today, celestial navigation remains an important backup system for ships and aircraft, especially in situations where electronic navigation systems fail. Moreover, celestial reference frames are essential for spacecraft navigation. By precisely measuring the positions of stars and other celestial objects, spacecraft can determine their position and trajectory with incredible accuracy, allowing them to navigate through the vastness of space. Section 6: Galactic Grids, mapping the Milky Way and beyond. Celestial reference frames aren't just limited to our solar system. Astronomers use similar systems to map the Milky Way galaxy and even the distribution of galaxies in the universe. By measuring the positions and movements of stars and galaxies, astronomers can study the structure, evolution, and large-scale dynamics of the cosmos. For example, mapping the motions of stars in the Milky Way has revealed the presence of spiral arms and a supermassive black hole at the galactic center. On a larger scale, mapping the distribution of galaxies has provided evidence for the existence of dark matter and dark energy, mysterious components that make up the vast majority of the universe's mass and energy. Section 7: Time and Space. The dynamic nature of celestial frames. It's important to remember that celestial reference frames aren't static. The universe is a dynamic place with stars and galaxies constantly in motion. As a result, celestial reference frames need to be regularly updated to account for these movements. Furthermore, Einstein's theory of general relativity tells us that gravity warps space-time, and this warping affects the paths of light rays. As a result, the positions of celestial objects can appear to shift slightly depending on the gravitational field they're passing through. Astronomers need to account for these relativistic effects when making precise measurements with celestial reference frames. Section 8. Future Frontiers, Expanding Our Cosmic View. As our understanding of the universe continues to evolve, so too will our celestial reference frames. Future telescopes and space missions will provide even more precise measurements of celestial objects, allowing us to refine our cosmic maps and probe the universe in greater detail than ever before. One exciting area of research is the search for extrasolar planets, planets orbiting other stars. By precisely measuring the tiny wobbles that planets induce in their host stars, astronomers can detect these distant worlds and even determine their mass and orbit. Celestial reference frames are crucial for these measurements, providing the stable framework needed to detect these minute stellar motions. Section 9. Conclusion: The everlasting allure of the cosmos. From ancient stargazers to modern astronomers, humans have always sought to understand our place in the cosmos. Celestial reference frames, the invisible grids that map the heavens, are essential tools in this quest, allowing us to chart the positions and movements of celestial objects with remarkable precision. As we continue to explore the universe and unravel its mysteries, celestial reference frames will undoubtedly play an even greater role in our understanding of the cosmos. They are the foundation upon which we build our knowledge of the universe, guiding us ever deeper into the vast and awe-inspiring expanse of space and time.